Hello and welcome to Radicals 2.1, square roots equals constant. Okay, so in this lesson we're going to solve for x. And yeah, that should sound very familiar because we've solved for x many times already. The only difference is this time the x is trapped inside of a square root. Okay, so to get him out of that square root, we're going to have to do something different that other problems don't necessarily need to do. But it's not like it's going to be super difficult. Yeah, it's a pretty simple step, and once you see it, you're going to be like, oh, is that it? I'm like, yeah, that's it. Okay, so let's just get started on our first problem, and yeah, enjoy what you see. All right, so let's get going. So we have, let's see, 4 square root of the quantity x minus 5 equals 24. Okay, so we want to get rid of the things that are attached to the x. So right now there's 3 things that are going to have to go away. The 4, the square root symbol, and the negative 5. Okay, so the first thing we want to get rid of is the 4. Yeah, you cannot get rid of the 5 first. You can't go plus 5 on both sides. You cannot do that because the negative 5 is trapped also inside the square root. Okay, so when you take away things that are attached to the x, you got to take away things that are outside the square root symbol first. Okay, because those are the only things that can interact with each other, because that 24 on the other side is also outside of the square root. Okay, so when you start getting rid of things, like I said, the first thing you have 3 identified things that are attached to your x or on the same side as x, your 4, your square root symbol, and your negative 5. And of those 3 things that I just mentioned, the 4 is the only thing that can be handled first. Okay, so to get rid of this 4, we're going to divide both sides by 4. Okay, so divide by 4 and divide by 4. Okay, so we're going to cancel out the 4's on the left side, and all we have left is square root of x minus 5 equals 6. Okay, so we still cannot just add 5 on both sides. I've seen many students do that before. You cannot add 5 on both sides at this point. That is absolutely bad. Okay, because that negative 5 is also trapped inside of the square root. Okay, so what we have to do next is we got to get the x and the negative 5. We have to untrap them from the square root symbol. And the only way that happens is to do the exact opposite of what a square root does. Okay, and the exact opposite or the inverse of a square root is a square. Okay, so instead of in the previous, I think, problems that we've done where we tried to get rid of x squared, right? I think in the last quarter we had x squared that we wanted to get rid of. So we square rooted both sides to get rid of the square, the power of 2. So now we're going to do the exact opposite. When we're trying to get rid of the square root, we're going to square both sides. Okay, so when I square both sides, here's what happens. Your left side becomes x minus 5, and your right side becomes 36. Okay, and now you don't see the square root symbol anymore, and now that negative 5 is able to be dealt with. So now you can finally deal with that negative 5, and the way to deal with it is exactly how you wanted to do before. You're going to add 5 on both sides, and you're going to get x equals 41. Okay, so here's where a lot of you guys are going to say, okay, we're going to call it a day, we're done. All right, but this particular section, here's what's going to be kind of irritating for some of you. Okay, I don't normally require you guys to check your answers, but in this particular problem and in the next couple of lessons after this, it's going to be a requirement to check your answers, and if you don't check your answers, I'm going to mark you down on your points on your quizzes and your exams. Okay, because what we have here is we have a chance for an answer that solved perfectly nicely, like x is equal to 41. We didn't make any mistakes whatsoever, but there's a chance that 41 does not work. And you're probably thinking, how would it not work? We didn't make any mistakes. We solved everything by the book. Everything looks good to go. Why shouldn't it work? Okay. Well, when you do what is called squaring both sides, which is what I did in like this, what is this, like third step or second step, whatever you want to call it, okay? We created what is called a chance for an extraneous solution, a solution that works within the framework of a squared problem, but it might not work when we put it back into the original problem, which is a square root problem, okay? And that's what we want to make sure we check for, that Yeah, x equals 41. It works when my problem is squared. It works fine. Yeah, but does it still work when I check it with the square root problem, my original problem? And that's what we have to verify. Okay, so, and I know you're going to say, oh my goodness, this is going to be so irritating that we have to check this answer. Well, like I said, sometimes you're going to get sections where you're going to get an answer and you're going to check your answer and it's going to be like, whoa, it doesn't work. And you have to cancel that answer out. You cannot submit that as an answer at that point. Okay, so let's check to see if x equals 41. All right, so we're going to plug it into our original problem. So we got 4 square root of, and I'm going to put a 41 in place of the x, minus 5. And then we don't know if it's equal to 24, so I'm going to put a little question mark above the equal sign because I'm not sure it's going to equal 24, but that's what I'm trying to verify. Okay, so that's why I put the question mark above the equal sign. Okay, so let's start playing with our numbers. And when you check your answers, here's what you got to realize. The left and the right side are not allowed to interact with each other. So you can't divide by 4 on both sides. Okay, you can't like add 5 on both sides. You can't make the left and the right side interact because those are things you do when the equal sign actually exists. Like the equal sign actually is something that is part of the problem. Okay, we don't know that if these two sides are equal, so we're not gonna play by our normal rules where we're gonna assume that it's equal, so we have to do the same thing on both sides. We're not gonna make that assumption. So when I check answers, you're only allowed to work with what you have on the left side, and you're only allowed to work with what you have on the right side. So since there's nothing else on the right side, I'm done at 24. Okay, so if I get my left side to become 24, that means that the two sides have 24 and 24. Then it means my answer is good to go. Okay, but like I said, I'm not allowed to interact the two sides. So I can't divide by 4 both sides. I can't square both sides. I can't do any of that normal stuff. I'm only allowed to work with what I have on the left side. So what do I have on the left side? Well, let's do it. I got a 4 on the outside. Then I got square root of 36 on the inside. Okay, then I know that the square root of 36 is known as 6 times 6, right? Because that's what 36 is. And since they match, and since they're in a square root, I'm allowed to circle the 6's. And because I circle them, they're allowed to go outside and join the 4 that's also on the outside. And when I make them combine, they make 24. So my left side is 24, my right side is 24. What do I conclude? These two sides match. So let's write the word match, or matches, and we're happy. You know why we're happy? Because that means this answer is good to go. So we can finally put this 41 on our answer line and we can say, yep, 41 is a legit answer. Okay, and this is what you're going to be required to do on every single problem in this lesson and on future lessons also that all deal with square roots and solving for square roots. Okay, so let's move on to number 2. Okay, so let's do this one. So let's write down the problem. So we got square root of x plus 9 and then minus 3 on the outside equals negative 1. Okay, so let's solve for x. So let's get rid of this negative 3 first. So we're going to add 3 both sides, right? We don't want to subtract 9. Yeah, we don't want to combine 9 and negative 3 and make 6. You don't want to do that because the positive 9 is on the inside the square root, and they're not allowed to interact. If you make them interact, game over. Your problem is done. It's never going to be correct. Okay, so I got square root of x plus 9 equals 2. Okay, then I want to get rid of my square root, and the only way to do that is to square both sides. So I get x plus 9 on the left equals 4. So finally, my 9 is no longer part of your square root, so I can subtract 9. Now you have permission to do it because 9 is outside the square root. Okay, you didn't have that permission earlier because it was inside the square root. Okay, so we get a potential answer of negative 5, and you're probably saying, why are you saying potential answer? And like I said earlier, we don't know if negative 5 is going to work. It's probably going to work, but there could be a chance that this is an extraneous solution, and if it's an extraneous solution, it looks good to go because we solved it. We're pretty sure we didn't make any mistakes when we solved it, but when I check the answer with the original problem, it doesn't work. Okay, so we're going to check x equals negative 5, and we're going to plug it into our original problem, and we're going to see if it works. So we got negative 5 plus 9 minus 3, and we don't know if it's going to be equal to negative 1, so I put that question mark above the equal sign. I put this barrier, this wall, that reminds me my left side and my right side are not allowed to interact. So my right side is done. That negative one is not going to change because there's nothing else on the right side. So I got to make sure that whatever I do, yeah, if I can make this left side turn into a -1, then -5 is a legit answer. Okay, so let's just do it. And like I said, do not make the two sides interact. Don't be adding 3 on both sides. Don't square on both sides. That is not how you check answers. If you check your answer wrong, then I'm not going to give you credit for the problem, full credit. And if you don't show me that you're checking your answer, you can't just say, "Oh, I did it in my head." I'm not going to accept that. You got to show me that you're checking the answer on your paper as well. Okay, I got to physically see proof that you're checking your answer. You can't just say, "Yep, I did it, and I did it in my head." No, I'm not going to accept that. I'm not going to accept you did it in your head. Okay, so let's do this. So we got square root of 4 minus 3. And then square root of 4 is going to be known as 2 times 2. And we're going to circle the 2 times 2 because they match. And because they're inside of a square root symbol, they get to go outside. So when it goes outside, oops, I forgot to write the minus 3 after that. Okay, so when it goes outside, it's going to be a 2 joined by the minus 3. And when I combine them, I get -1. So I circle that and I compare it to the right side. So compare the left side number to the right side number. I got -1 on the left. I got -1 on the right, so they match. And they match, so I'm happy. You know why I'm happy? Because this answer works. So I can put, oops, I don't have to write the x actually because it's already written. So I can just write -5 on my line right here. Oops, change it back to pen. And I'm done. Okay, next problem, number 3. Okay, so we got, let's solve for x. Oops, wrong color. Back to blue, back to blue, back to blue. Okay. So I got 3 times quantity square root of x minus 2 plus 14 equals 2. Okay, so since I'm solving, I can make the two sides interact. So you got some choices. You can either divide by 3 first, which I don't recommend, or you can subtract 14 first, which is what I recommend. Okay, so we're going to subtract 14 first. Because if you divide by 3 first, you're going to make a whole bunch of ugly fractions, so you don't want to do that. So let's subtract 14 first and see what happens. So I get 3 times the square root of x minus 2 equals -12. Ooh, what is that line there for? I don't want you guys to think that's a negative sign, so let me just erase that. Okay, then we're going to divide by 3 rather. And then I'm going to get square root of x minus 2 equals -4. Okay, then I'm going to square both sides. And I get x minus 2 on the left side. And I get 16 on the right side. Okay, and last step, plus 2. Oops, where's my red? I thought I put red. Okay, they're going to add 2 on both sides. And we're going to get x equals, and I'm kind of running out of space, I'm going to put it on the side here, x equals 18. Potentially equals 18. I don't know if it actually is 18, but that's what we solved. So we're not going to be sure until we actually check our answer. So let's check our answer, and if it works, then cool. Then I can officially submit 18 as an answer. So we're going to plug it into our original problem. So 3 times the square root of 18 minus 2 plus 14, and we don't know if it's equal to 2, but that's what this whole process of checking verifies for us. Okay, so let's do this. So let's draw my little line, my wall, to signify I cannot allow the two sides to interact, and since there's nothing else on the right side, I just circle that number because I want to make sure that when this is all done, I get the same number on the left side and the right side. So if I end up getting a 2 on the left side, it matches with my 2 on the right side, and I'm good to go. 18 is a legit answer. So let's see if this works. Okay, so let's play with some numbers. So 3 times the square root of 16 plus 14. Okay, so let's see what else. 3 times the square root of, and let's see, break apart 16, and we can break it up into 4 times 4. And then since the 4's match, I can circle them. And because they got circled, they get to go outside and join the 3 that's already out there. Yeah, they get to join that 3 that's already out there. And let's continue on. So we get 12 plus 14, and that makes 26. So when I compare left side and right side, what do we conclude? Does it match? Because if it does, I'll draw the happy face because 18 works. Yeah, but does the left side and right side match? No, it doesn't match. Not match. So we're kind of sad. We're kind of bummed. Sad face. Because what does that mean? It means that we cannot use this answer. This answer is no longer acceptable. So do we actually have an answer to submit? No. So we're going to write on this blank, no real solution. Because we don't have an answer, right? We thought we did. We thought 18 looked good. It did look good. But when I checked the answer, yeah, it didn't work. It didn't make the same number appear on both sides. Did I make a mistake when I did my calculations on the left side? I don't think so. Looks good to me. Yeah, so sometimes you're going to get a not match scenario where the answer looks perfectly good to go. 18 looks good, or it did, right? But it doesn't work. It happens. Okay. So let's go on to our last problem. Okay, so we got 5 times the quantity, 2x plus 1, in the square root rather. Okay, I kind of said it wrong, sorry about that. Minus 11 equals 19. Okay, so let's start playing with some numbers. We're going to add 11 on both sides. And we get 5 times the quantity. I said it wrong again. 5 times the square root of 2x plus 1 equals 30. Okay, and then we're going to divide by 5. Divide by 5, divide by 5. And we get square root of 2x plus 1 equals 6. Okay, so then we're going to get rid of the square root. So we're going to square both sides. And I think I'm going to run out of room this time. So square both sides, but that can easily be fixed. I can just page extend. Yeah. Okay, so I get 2x plus 1 on the left side equals 36 on the right side. Okay, and then I'm going to subtract 1. Well, yeah, this problem is way longer than the others. So subtract 1, and I get 2x equals 35. Divide by 2. Let me page extend again. Divide by 2, divide by 2. So I get x equals 35 over 2. And can that fraction be simplified? I don't think so. I don't think 35 over 2 can be simplified. I'll just leave it like that. Okay? So it's my potential answer. I don't know if 35 over 2 is going to be actually good to go. Right? That's what we're checking it for. Okay? And don't forget, you have to check this answer. If you don't check the answer, you're not going to get given full credit. So we're going to check 35 over 2. We're going to plug it into our original problem. And I did it in the wrong color. I kind of want to use purple when I check answers. Okay, so I got 5 on the outside, square root of 2 times 35 over 2 in parentheses, plus 1 also in the square root, minus 11, and maybe it equals 19. We don't know yet, but we're just going to check. That's what we're doing this for. Let's draw my line, my wall. So if I get a 19 on the left side, then we're good to go. They match. Okay, so let's see what happens. So we got 5 times the square root of 2 times 35 over 2 is basically 35, because the 2's cancel, right? The 2 on the top, the 2 on the bottom, they cancel out. So all I have left is 35 plus 1, and then minus 11. Then I got 5 times the square root of 36 minus 11. Then I'm going to break apart the 36 to be 6 times 6, which they match. And because they match in a square root symbol, I can circle them. And they're going to jump outside and join the 5 that's waiting patiently for them. So it's going to be 5 times 6 minus 11, which becomes 30 minus 11, which becomes 19. So 19 is my left side number. 19 is also my right side number. So these guys match. And is that what we wanted to see? Yes, of course it is, because it makes us happy. So that means that 35/2 is a legit answer, and we're going to submit that on this answer line right there, 35/2. All right, so that's it for these problems. Good luck, good luck, good luck. And like I said earlier in this lesson, don't forget to check your answers. It is going to be mandatory this time. For this lesson and the next couple of lessons coming up after it, it's going to be mandatory. You don't have a choice. Okay? Well, you do have a choice. If you don't want to check your answer, I'm just not going to give you full points. Okay? But I don't think you want that. So please, please, please check your answer. All right? So good luck with this lesson, and I will see you in class. Bye-bye.